Classifying chemical reactions. We're going to classify chemical reactions into 4 different types. The first type of chemical reaction we'll look at is the synthesis reaction, where we have 2 reactants, A and B, for example, going together to form one product. The second type is decomposition, where we have one reactant that breaks apart into 2 or more products. We're going to look at single displacement. Single displacement is where we have one reactant come in and displace another reactant in a compound. So A displaces B to form compound AC, and B gets left by itself. It's displaced. We are going to look at double displacement, or it's also called double replacement reactions, where compounds basically swap partners. A and B were together, but A and D come together in the products. A and B were together, but B and C come together in the products. Synthesis reactions occur when 2 substances combine to form a compound. Sometimes these are also called combination or addition reactions. Here we have one reactant plus another reactant makes a product. It actually could be more than 2. You could have 3 reactants going together, but you're always going to form just one product. So basically A plus B goes to AB. An example would be 2 hydrogens plus an oxygen forms water, 2 water molecules. This is a synthesis reaction. Another example would be carbon plus oxygen forms carbon dioxide. Let's look at some more synthesis reactions. Here's another example of a synthesis reaction where we have potassium metal. So we have potassium metal reacting with chlorine gas to form potassium chloride. Let's do some practice. Predict the products and write and balance the following synthesis reaction equations. Sodium metal reacts with chlorine gas. We have sodium metal reacts with chlorine gas, then what's the product going to be? We're going to go together to form sodium chloride. Okay, and if it's a solid and that's a gas, then the sodium chloride is going to be a solid. Solid magnesium reacts with fluorine gas. When solid magnesium reacts with fluorine gas, then we get magnesium, and we're going to need 2 fluorines for 1 magnesium, because remember, magnesium is a 2+ charge, so we need 2 fluorines, and that would be a solid. How about aluminum metal reacts with fluorine gas? We get aluminum, and aluminum has a 3+ charge, so we have to have aluminum fluoride, AlF3. Okay, so if we have aluminum fluoride, AlF3, oh, let's go back and balance. I forgot to balance. We need to put a 3 there. We'll need to put a 2 there. We'll need to put a 2 there. Magnesium fluoride. If we have magnesium fluoride, we're balanced there, and our sodium chloride, we're not balanced there, so we'll put a 2 there. We have a 2 there, so we have a 2 in the sodium, so we'll put a 2 there, and that balances. Decomposition reactions. In decomposition reactions, they occur when a compound breaks up into the elements or into simpler compounds. For example, you would have one reactant go to 2 or more, could be 2, could be more products. Okay, in general, so you have AB break up into AB, or it could be ABC break up into ABC. Example, 2 water molecules breaks up into hydrogen and oxygen. So this is a decomposition reaction. Another example, 2 mercury oxide molecules break up into mercury and oxygen. Another view of a decomposition reaction. Here we have our mercury oxide molecule. So we have our mercury oxide, that's a solid crystal lattice. We heat it and it breaks up into mercury liquid in a test tube after you've heated the solid, the mercury, and the oxygen gas. Do some practice. Predict the products and write balanced equations for the decomposition reactions. Solid lead 4 oxide decomposes. Solid lead 4 oxide decomposes. So how are we going to write? So it's going to decompose into lead solid and oxygen gas. Okay, and that's balanced, so that's a decomposition reaction. Okay, aluminum nitride decomposes. So when aluminum nitride decomposes, it decomposes into aluminum and nitrogen. Nitrogen is one of those diatomics, so it has to occur in a pair. It'll be nitrogen gas. This would be aluminum solid. Okay. Okay, so we have aluminum nitride that decomposed. So here we have we need to balance this equation. We need to put a 2 here and a 2 here in order to balance this decomposition reaction. Okay, let's do some more practice. Identify the type of reaction for each of the following synthesis or decomposition reactions and write the balanced equation. So let's get our pen. Okay, N2 plus O2 forms nitrogen monoxide. Remember, nitrogen monoxide would be NO. Okay, so that's nitrogen monoxide. We're going to need to put a 2 here. This is 2 things going together to make 1. So this is one we would call a synthesis reaction. Okay, barium carbonate. So barium carbonate is going to decompose, and it will decompose into barium solid and carbon dioxide gas. I don't have quite enough room, but it's okay. So if we do that, then we'll need to put a 3 here, I think, and or maybe not a 3 there. Let's see, CO2. Oh, I know, this would break apart into barium oxide. So barium oxide, solid, and carbon dioxide gas. So then you would have 3 oxygens, a carbon, and a barium, so you don't need this 3 after all. Cobalt and sulfur make cobalt be cobalt 3, so cobalt that would be the equation for cobalt sulfide. Oh, and this is a decomposition reaction, right? Because we decomposed barium carbonate. Okay, this is a synthesis reaction. We synthesize 2 things. Okay, nitrogen triiodide. Break that apart into nitrogen gas an iodide gas. Okay, if we put a 2 here, okay, then we put a 3 here, we're balanced, and this is a decomposition reaction. It's where this breaks apart into 2 or more things. Okay, single replacement reactions. And single replacement reactions occur when one element replaces another in a compound. A metal can replace a non-metal, can replace, or a non-metal can replace a non-metal. So in single replacement reactions we're always going to have an element plus a compound gives an element in a compound. So it goes, we'll have something like A comes in and bumps out B, okay? And so now A and C are together and B is by itself if A is a metal. Okay? If A is a non-metal, then A comes in and bumps out C, okay? And B and A get to be together and C is bumped alone. Remember, the cation always goes first. So when H2O splits into ions, it splits into H plus and OH, not H plus and O minus 2. Okay, let's look at a single replacement reaction. Here we have lithium. We have lithium, we have water, so we have lithium going in. Think of water as being HOH. Okay, lithium is going to go in and replace hydrogen in the water, and the hydrogen has to go home alone. But it goes home alone as H2 because elemental hydrogen is H2. Write and balance the following single replacement reaction equations. Zinc metal reacts with aqueous hydrochloric acid. Okay, well, let's balance it. So we have zinc and hydrochloric acid, zinc chloride and hydrogen. So we have one zinc here, one zinc here. You have one chloride here, 2 there, so we need to have a 2 here. Okay, so this is a single replacement reaction where this metal comes in and displaces hydrogen, and hydrogen gas is produced, and zinc chloride is formed. So zinc replaces hydrogen in HCl, and this is called a single replacement reaction. Sodium chloride solid reacts with fluorine gas. Okay, if sodium chloride solid reacts with fluorine gas, then we're going to have fluorine is actually going to be replacing chlorine. So we have fluorine come in and replace chlorine. Chlorine goes home alone, and sodium and fluorine make a partner. Now we do need to balance this, so we'll need a 2 there and we'll need a 2 there. That's called a single replacement, sometimes also called a single displacement reaction. Aluminum metal reacts with aqueous copper 2 nitrate. Okay, let's balance this one. Okay, aluminum comes in. Okay, if aluminum comes in, then it's going to make a compound with nitrate. So aluminum is +3, nitrate is -1, so we're going to need 3 nitrates for 1 aluminum. You guys do remember that. Aluminum, 3+, nitrates, one of the polyatomics you have to know. Okay, when they crisscross, they become aluminum nitrate. and that is going to be aqueous because it's got water in there and nitrates dissolve in water, but we're going to get out some copper solid. Okay, copper solid comes out. So we have 3 nitrates here, we have 2 there, so we're going to need to put a 2 here. Okay, we put a 2 here, which means we put a 2 here, and it doesn't make any sense because we need a 3 here. 3 here because that gives us 3 nitrates. It means 6 nitrates. So we have 3. Sorry, that looks so messy. And then that gives us 3 coppers over here. Now, double replacement reactions. Double replacement reactions occur when a metal replaces a metal in a compound and a non-metal replaces a non-metal in a compound. It's always a compound plus a compound gives a compound plus a compound. So in general, they just swap partners. So A gets D and B gets C. Okay, notice C is the cation, so C comes first. A is the cation, so A comes first. Okay, so let's look at this example. Silver nitrate plus sodium chloride gives silver chloride and sodium nitrate. So we've got silver and chloride came together to make silver chloride, and sodium and nitrate came together to make sodium nitrate. Always write the cation first. Another example, here we have potassium sulfate. So potassium and nitrate came together to form potassium nitrate, and barium and sulfate came together to form barium sulfate, and that's a solid. Okay, this is also one of those precipitation reactions we've already learned how to predict. So we have a precipitation, we have a precipitate that formed this solid barium sulfate. Here we had a precipitate form this solid sodium chloride. Double replacement reactions don't occur unless a precipitate forms or unless it is an acid-base reaction like we've seen. So acid-base reactions and precipitation reactions are forms of double replacement reactions. Now let's do some more practice and predict the products for these compounds, for these reactions, and what type they are. Okay, here we have a compound and a compound. So we are going to have hydrogen and nitrate and silver and chloride. So we're going to form nitric acid, HNO3, and silver chloride. And that will be a solid. Okay, so what type is that? That's a double displacement reaction. I'll write DD for double displacement. Here we have calcium phosphate and sodium chloride. So if we have sodium chloride, that's aqueous, and calcium phosphate, okay, so formed sodium chloride and calcium phosphate, and that was a double displacement reaction, and this would be a solid. Okay, we've got lead goes with chloride, barium goes with nitrate, so we get lead chloride, and our second product is barium nitrate. and we need 2 nitrates. Okay, and that would be aqueous. Okay. These are all double displacements. Okay, here we have iron hydroxide and sodium chloride. So sodium chloride and sodium chloride and iron hydroxide, and we have iron 3, so we know we're going to need 3 hydroxides. Okay, and we have sulfuric acid and sodium hydroxide, so this is going to be an acid-base neutralization reaction. We have H2O and why my pen is writing so weird, sodium sulfate, okay? H2O is a liquid, and that's what makes this form, okay? That's a acid-base neutralization reaction. Here we have potassium going with sulfate and copper going with hydroxide to form copper hydroxide. Let's change our pen color. Copper hydroxide. I'm just not having good luck with my pen right now. 2 copper hydroxides and potassium sulfate. Okay, may not have gotten all of those balanced, but we predicted the products and they're all double displacements. Okay, the 5th type of reaction that we're going to look at are combustion reactions. Okay, combustion reactions occur when a hydrocarbon, so a carbon and hydrogen containing compound, reacts with oxygen gas. It's also called burning. In order to burn something, you needed 3 things in the fire triangle: a fuel, which is a hydrocarbon, oxygen to burn it, and something to ignite the reaction, something to start the reaction, or a spark. Okay, in a combustion reaction, in general, we have hydrocarbon that reacts with oxygen to give carbon dioxide and water. Okay, so product in combustion reactions are always carbon dioxide and water. Combustion is used to heat houses and run cars. Octane is gasoline. Okay, so here's an example. Let's see if we can balance this equation. I hope our pen works better. Okay, here, whenever you're balancing a combustion reaction, you want to balance your carbon first. Okay, so we have 5 carbons here, so we're going to need 5 here. Okay, and then you balance your hydrogens. We've got 12 hydrogens over here, and we've got 2 over here, so we put a 6 here, and that gives us 12. Now we've got to fix our oxygens. We've got 10 here, so that's 10 oxygens there, we've got 6 here, so that equals 16 oxygens. So that means we need to simply put an 8 there. Let's write the product of this reaction. So we know the products are going to be CO2, gas, and water liquid. Okay, but we need to balance it. We've got 10 carbons here, so we put a 5 there. Oops, not a 5. We've got 10 carbons there, then we have to put a 10 here. Okay, we have 10 carbons, then we balance our hydrogens. We've got 22 hydrogens there, so that means we have to put 11 right here to have 22 hydrogens. So now we've got 20 oxygens here, we've got 11 here, 11 oxygens here, for a total of 31 oxygens. We've got to have 31 oxygens on this side. So what can we multiply 2 by to get 31? Well, how about 31 halves? We can use a half, 31 halves. Now all we simply need to do is multiply through the whole thing by 2. That cancels that 2. This becomes a 20. And this becomes a 22. And we've balanced our equation. 2, 31, 20, 22 for that combustion reaction. Okay, here's mixed practice. Let's state the type and predict the products and balance the following equations. Okay, barium, we have a compound and a compound. So when we have a compound and a compound, we know that we're going to have a double displacement reaction. So here we're going to have barium sulfate and HCl. Okay, this will be a solid. This is aqueous. Okay, now we've got to put a 2 here to balance this, and now that should be balanced. Okay, this is a combustion reaction, so the products are always for a combustion. CO2, gas, and water. Liquid. Okay, so we have that. We have 6 carbons over here, so we need to put a 6 there. We've got 12 hydrogens here, so we put a 6 here. It gives us 12 there and 6 here, so it gives us 18 oxygens overall, so we need to put a 9 here. This is a combustion reaction. This one was a double displacement reaction. Okay, here this is going to be an element reacting with the compound, so zinc is going to come in, replace copper, so you get zinc sulfate. Okay, zinc sulfate, and we're going to get copper solid. Okay, so that is a single displacement reaction. Here we have a synthesis reaction where we're forming cesium bromide. So cesium bromide. Okay, and cesium bromide we would have to put a 2 here and a 2 here, and that is synthesis. Okay, now we have a decomposition reaction, so I would say this would decompose into iron oxide, that's a solid, and carbon dioxide. I don't know why my pen starts freaking out. Carbon dioxide gas. Okay, and that is a decomposition reaction. Okay, so for some suggested textbook practice, I want you to do example 7.15 on page 232, end of chapter example 7.25, end of chapter problems 89 through 92. Practice as many of the blue problems in the back of the chapter as you can. Check in the back of the book.